Hi and welcome back to the show. Yeah, the ICOM IC-7000 story is getting to its end. So, as you have seen my earlier video, you have seen that we had some trouble with the ICOM radio here on the bench, and that we have an intermittent failure. But well, you know, sometimes you will really be able to fix those things as well. And so we did. And I will show you what we found. I mean, you know, I've already told you that we were really trying hard to heat it up, to cool it down, to use freezer spray, and that we didn't get any reaction. But then, a couple of days ago, I had the radio, as I already told you, running beside another repair, and yeah, I just press PTT once in a while, and suddenly I saw on my dBm meter, so that is what I've shown you in the last video as well, that suddenly the output signal was dropping. And while the output signal on my dBm meter was dropping, because that was the signal coming from the main board, right? When I saw that dropping, I recognized that, of course, then the output power in general was down. And so I was very much convinced that the problem is on the main board, right? And therefore I thought, well, let's check if we cool it down by freezer or with freezer spray. And I sprayed over the board just to see if I see a reaction. And then I suddenly saw that the meter needles are bumping back and forth. And I thought, so there is an area which is very sensitive. But I recognized that it was not a heating or a heat problem. So it looks like a little bit funny to me. And I thought by myself, that must be a kind of open soldering point or such. And I investigated then more in depth this area by poking around with my tester, and I've observed the whole area by using a microscope, and then I found this little devil. And let me show it to you, because I haven't repaired it right yet. But I mean, okay, the troubleshooting has been done, of course, but I can show you what the problem is, and we can repair it together. So let me get you to the bench. Okay, and we are on the bench. We have our radio in front, and well, maybe now you can't hear it really, but radio is receiving here on 2 meter, so without any problems. If we go over to our screen, you see that we have a crisp and clear audio signal out of our receiver, so that is telling us that the radio's receiver is working just fine. And yeah, let me show you the process I've done where I recognized that something is wrong. Just to remember, we use this meter up there, called millivolt meter, but I used it in dBm mode, and I was monitoring the output from the main board. That is what I've told you, and I saw that that was dropping. And subsequently I saw here on my output meter So now power meter, not output meter, on my power meter, which is recording the output power in watt, as you can see over there. And I was recognizing that it was bouncing back and forth while the signal were dropping up there. And that is what I've told you in the intro that told me that there must be a problem on the main board. And that was, you know, a very important step forward to understand where we really have to look for the problem. Well, and then it was quite easy, so I took here my freezer spray and I simply sprayed here over the whole area. And then, as I told you, suddenly I recognized that we have our meters bumping back and forth. And the area where I was quite sure it was related to is here in this edge here, right? In this edge. And when we go closer, and then we came really to this area here, and I was recognizing that the problem needs to be here, and I was taking here the signals out of this IC. We will have a look what this IC does, and then yeah, I was quite sure that we are in the right direction. And then, as I told you, we started to observe the problem with the microscope. So let's see if I can show you what I have seen under the microscope. Alright, so I have prepared the area which I've told you that it is very sensitive down there to your view. And well, you see here the IC, and you see here some marks from probing around. But the IC itself was fine, and the output signal here at the IC just fine. But then I recognized, and I hope you can see it a little bit on the video, that this little capacitor, can you see it? That this capacitor, maybe you can really see it. I do not want to really crack it out, because we still need the trace to get a new component in. But I hope you easily can see that we really have a crack here, right? And you may think, well, a little capacitor, so what can that make the problem so serious? So is it maybe a blocking capacitor or such, which would not really or completely describe why the signal is dropping? And therefore, of course, we need to have a look into our schematic, and even so we need to know what this IC is for, because without understanding what's going on and what the components are for, we do not really know what we are doing, so then we would still poke in the dark. So therefore, let's go into the schematic and let's see what we have here. Well, of course, what we need to do first is to have a look onto the board view, and of course we need to enlarge it until we are really able to see what's going on. And yeah, I guide you through. I mean, we do not know to search it now because I know where it is. And yeah, let me enlarge it here a bit more, and you may already, hopefully, let me see what you can see. Are we already there? Not sure. Let me enlarge it a little bit more. Yeah, and maybe one more. And now it might get clear. So we are talking about the IC-13001. So that is the one which you have seen on the board. And we are talking about this little capacitor here, which is C1310, I believe. So let me enlarge it a little bit more. 1310 seems to be right. So we need to understand the function here of the C1310, and therefore we need to go to the schematic. I mean, we are looking for the IC1310, and for the we are looking for the IC1301 and for the C1310. And let me change over to the schematic. And here we are on the schematic for the main board. And very confusing, I know. So let me enlarge it again. And we are getting very much closer. Here we have the IC1301. Maybe we enlarge it a little bit more. Well, just only from the schematic, we do not directly know what this component is doing. I mean, now we have two ways. First, we could simply go to our block diagram, which we will do. And secondly, of course, you can go to a data sheet for the IC1301, which is a TA4107 Foxtrot. So looking into, the data sheet would tell us what this IC is doing. But here in our case, we have the block diagram, and therefore we see what the block diagram is telling us first. One step maybe in between. So we see here, of course, this orange signal line. And you already see, no, you don't see it. I have to get it here into view, and then you see here TXIF. So we know two things. First, the orange line is really the transmitter line, right? So that is a transmitter pass. And then we know that it has something to do with IF, intermediate frequency. And to know a little bit more what we are talking about and what this IC1301 is doing, as I told you, let us go back to the block diagram. Here we have our block diagram, and I've already enlarged it a little bit for you. Interesting might be again that you have here the explanations for the different colors. So orange is TX, green is RX, and blue is common. So that is important to know. And of course, I'm already here in the area where we have our IC, what we are talking about. And yeah, now you should be able to see it. And once again, orange line, so transmitter line, and that means fine. we have a drop of our power output. So that means that is right. And the IC-1301, a lot of you guys would already have seen it, is a mixer. It is a mixer. And a mixer means if there is an interruption in the path in any way, then of course our signal towards our PA stage will drop and you won't get any output power. Simple as it is. So now we know it is a mixer. A mixer is always additional to that it is mixing a local oscillator frequency and the signal itself. It has also a little amplification. Yeah, it amplifies a little bit the signal additional to the main purpose of mixing signals to the new IF. And you can already see after the mixer we have already here, following here our orange line, our IF amplifier, which is dedicated, you can see it, to the TX path only, right? So therefore we cannot expect from this signal path to have an impact on receive. And that is the reason why our receiver is working just fine, but transmit is going down. So that is what we see. Right, let's go back to our schematic. All right, here we are. So now we know that the information we have seen here, TXIF, is now very much logical. We know that our IC is nothing but a mixer, very nice. And we know that here on our signal path, pin 5 of our IC is the output of our mixer. And now you see why you really get a transmitter power drop, because the C1310, which we have seen as cracked, is here a coupling capacitor. And of course, if the coupling capacitor is broken, is cracked, then it is clear that the signal will drop. And the time, it was the time where we were searching for the problem, this little capacitor was sitting somehow in its place, and it made intermittent contact. And it was such good that it was working for over 95% and only very low where, you know, it was not working. Now where we have found that we have a crack here, and when I was down here with my tweezers and whatnot, of course now we made the problem more worse, and therefore now we have the problem always. That is clear, because now, you know, we were moving it a little bit, and therefore now we have it interrupt completely. But now let's go and let's replace the C1310, which is, as we can see it here, 0.1, means that is a 100 nanofarad capacitor. So that is, as we have seen it, a little ceramic capacitor. Let's now replace it and let's see if it works afterwards. Now, before we go to replace here our component, so you see I press PTT, and you see that the PTT light is coming up, so the radio itself is switching to TX. But here on my watt meter you do not see nothing. And that is because our component has now moved too much. So maybe let me try if I press it down a little bit, if we can get it back working, but maybe not. But let me see if... yeah, you can see it. So when I'm here pressing, so I'm just tipping a little bit on onto the component, you see it, and you see that I'm able to give him a stimulus to go back to, what is it, 50 watt output power. But when I take my tweezers away, it is dropping. So that is more or less, you know, the proof of that is a fault we were looking for. So now let's go down to the component and let's simply get the broken one out. Hope that we do not lose our trace, which is down there, right? There, down there is our little component. Let's try to get it out, replace it, and then we see what it is. Alright, so let's try to swap it out, and as we already discussed it, it is a little bit delicate here. So let me try to do it as carefully I can do it, and I'm really not happy here with the situation on board, since we really could be able to destroy the trace, and that is what I'm most frightened about. Alright, so I first of all try oops, not good, really not good. Okay, I'm back. Do you see it? Let me check it. Yeah, you can see it. Alright, so let's try to get a little bit fresh solder to it. Okay, so let's try. You can see that it is already almost impossible, but maybe I've gotten a little bit fresh solder to it, and okay, so let's go ahead. If you do not want to see the whole process, simply use fast forward, but there are many of you who really like to see the process, and sorry, that takes a little bit time. Alright, so let's see if we can really get it out now. You see it is already broken. I guess I was able to protect the first solder pad, and now we need to get the other part, and I think we are lucky. I think we are lucky, so that really looks good. Yeah, that is really always a problem, that you potentially could destroy, you know, here our pet, which is of course then no fun, of course. All right. Let me see if we can get here a little bit more light. Okay, maybe so. Now we need to clean the pets, of course. First, additional flux, and then we need to clean them. Of course, it takes time. Right. Preparing my soldering iron. Get to temperature. Okay. Now let's see. Very nice. Both pets are clean. Now I can switch off the sucker here. Looks not too bad. I need a Q-tip. And I need some alcohol. Yeah, as well for drinking, of course. And let's clean the area here. Oh, looks good. That is looking quite nice, no problem. And now I need to find the right component, not only the right value, so we need a component which fits to this little area here. Okay, so I have here my little storage, and that are 100 nanofarad capacitors. It is a 0603 size, and we will double check if those fit. And you see it's already empty. I have to reorder some of those here. Alright, so let's try to get one component out. Let me get one component out, so come on. So here, oops. Yeah, now I've lost it. And I do not see it. Alright, I have to do one step in between. I need to find my lost little component. Okay, I found my little component back, but as you can see, and it is even so small, but still what I have here is a giant component compared to what we need to fit in here. So that means I'm struggling here because yeah, let me see what I have else in stock. But I believe, whoa, I have to order another one, or let me see, I have a donor board, and there I hopefully will find 100 nanofarad in the right size. We will get it managed. Okay, and from a donor board I have here, you can see it down there. That little guy is 100 nanofarad, and I hope that will fix. So I've tested it with my LCR meter. So it is definitely a 100 nanofarad capacitor. So let's see. Okay, so here is a little guy from the donor board, and we really have to be careful not to lose it. And you see, it would fit. That means the only job we have to do is to get this little component in. Right? So that is now our job, and therefore, of course, we have to prepare it here. Sticky. It is sticky. It is sticky. Oh yeah. Alright. So now I have it out of the way, and I need to prepare it here a little bit more. And the first I do is I prepare here our solder point a little bit. Okay, some flux, which is always very, very helpful. And now I put a little bit solder onto it. Okay. Very nice. So that is exactly the amount of solder we need. And now it gets delicate again. I have to reposition here a little bit my setup. Okay, so now I have repositioned the radio a little bit. I have grabbed another tweezers, and well, but still very delicate, as the access is very difficult here from all the sides. It is very, very close together all. Now let's see if we can get it managed here. The problem is I need to get it that much into position that I have a little bit of space here on the other end as well to get solder to the pad. As I can see it, it should be fine. Okay, so let's try to get a little bit additional flux to exactly that point. Yeah, hope that will work. The solder I'm using here, by the way, is that thin that it is incredible, and the area I'm working here is as well very, very delicate. Found it. Maybe a little bit too much, but that does not make here any problems. And that end as well. So both ends are looking quite nice. I'm fine with the result. No problems. Now let me check it here once again and clean it. Yeah, we need a good connection for sure, good continuity and good solder points, which I believe looks fine. Looks fine. Let me once again check it here. Yeah, value is just fine. Value is just fine, perfect. And you know, normally you can not test in circuit, but I've done it out of the circuit to be sure that it is the right value. Okay, so everything looks perfect, right? So let's go ahead. Right, everything prepared for testing. Radio is already back connected to our power supply. Now let's cross fingers. First of all, okay, so you may hear it. It is still receiving very nicely without any problems, but that is not what we are looking for. So let me go over to our watt meter and let's see if our repair was successful. Okay, so you can see my amplitude controller here, and let me go closer. Just if anyone asks, there is a 10 dB attenuator just in front, so that means if it is showing 10, right, it is 100 watt. If it is showing 10, it means 100 watt because of the 10 dB attenuator in front. So let me go closer, and now let's maybe do it here this way. Maybe so we can see the TX light. And now let's test. 100 watt, and we can read it is 55. So it looks pretty nice. So what we have done is more than successful. Receiver is working, transmitter is working, everything is honky donkey, and we can be really happy with the repair. And of course the owner in general can be happy that we were able to get it back to life. Right, and that's it for today. I hope you enjoyed a little bit, and goodbye to everyone. Take care and catch you next time. Bye.